The MacBook Pro M2 Max has been my main production computer for my latest 3 to 5 complete Ableton Live 11 projects with mostly software plugins. My projects, they tend to get quite heavy on the CPU and the resources of the computers I use, and there are several reasons for that, and I thought we can take a look at my latest finished project in today's video and see how the performance are on a one of the latest Apple computers. The track is called Resonance Frequency, and if you want to listen to it, there are links below if you are interested. So I really like the warm analog synth sounds, and I have a Moog here. Many of the instruments in my tracks are using Diva, and Kniphonium is one of the synthesizers. Those are plugins that are quite heavy on the CPU, but they sound really good in my opinion. That's the reason I use them. And on some of these tracks, I also use Ableton's built-in effects, such as the LFO, to automate different parameters on the synthesizers in real time, which can give the sound some more extra unique character and try to get the sense of more unstable or analog unstableness, if you will. Stick with me in this video and I will show you what I mean later on. And this will naturally increase the need of processing power from the computer, because you adjust parameters on the soft synthesizers in real time, requiring the synth to do more calculations. My external synthesizer, the Moog, is just a audio file. I've just recorded it and it's in the project. It doesn't demand that much at all, unless I have a lot of effects on it. Also, one thing I am pretty bad on is using return channels, send effects. I have a bad habit of inserting reverb and delay effects directly on the instrument track when it isn't really needed. It could be used as a return track instead and shared with other tracks, so you don't have to use like 5 reverb plugins. You can use one instead, and that will naturally decrease the CPU load of the system as well. The project in this video is running on the MacBook Pro here. It's the, as I said, the M2 Max, and the project is in 48 kilohertz, and I am using a buffer size of 512. I know I can bump it up to 2048, but I feel like the project is getting so laggy if you increase the buffer size, so I think 512 is kind of well, it feels like a good sweet spot when you produce mostly in the box. I'm going to play different parts of the track just a few seconds, and we can take a look at the CPU meters. One CPU meter is in Ableton Live. It's actually the audio buffer meter, and we can also take on the bottom corner of my screen, take a look at the CPU meter for the actual system, for the actual Mac, when I'm playing through the track, and we can discuss the results after that, or you can skip if you want. Okay, so let's do this. So it's a melodic house trance hybrid type of track, and let's just start it off here and take a look at the CPU meter down here and the CPU meter up in the top right corner there. So here our Diva is starting. You can see the CPU goes up a little bit when Diva is introduced here. There are more Diva tracks coming here as well. crackle there. See a CPU overload over here on the audio buffer, but not actually on the system here. Getting some crackle. I didn't get crackle when I tested this before, but obviously it's because I probably are screen recording this. Yeah, it's just crackling. It worked fine. Let's see if we can turn off some quality. Let's talk about this later. Just see if we can get it to play. Yeah, let's take a look. Okay, I guess you get the point. It crackles. We are obviously reaching the limits of the audio buffer, not necessarily the system. And but maybe you have seen other videos like, oh, this Mac, it can play 300 tracks of Serum, and I only have like 38 tracks here. What's happening? Well, we are going to take a look and see what is happening here, because I'm a nerd and I find this a little bit interesting, and since you apparently do that as well. So I need to make something clear here. There are two different types of CPU load. You have the one you see here in Ableton Live in the top corner. That is the audio buffer load, and we can see that it averages around 85 or 90% in the busiest parts of the track here when we see that the Diva synthesizers came in. And if we take a look here, it also lights up the CPU light and indicating that the CPU is overloading. When I was testing this without screen recording, I could hear a little crackle there, not as much as crackle as you hear now in this video. So obviously my screen recording is using up some of the resources. But the CPU load you see in the bottom part of the screen shows all of the CPU cores on this actual Mac, and it shows the CPU load of the entire system. And as we can see here, it's touching around I don't really see the average, but I would assume it's around 60% perhaps, 60-65%. So there is a discrepancy between the two numbers, between the audio buffer range in Ableton Live and the system load. And this is not something that is wrong or uncommon. This is pretty usual in music production software. As I quickly go through all of the tracks here, we can see that there are effects and processing on more or less every track in this project of mine. This is actually one of my better tracks in my opinion. But all tracks have at least an EQ and a compressor, bread and butter plugins you often use. And on some tracks I also have plugins such as Soothe 2, for example. This plugin is also one of those that can get quite heavy on the CPU if you overlook the quality setting you have over here. Some software synthesizers might have quality settings you can change. On Soothe 2, as you saw, you have a quality setting when you are running the project in real time, and you have another setting when the system is exporting the project. So that way you can have a lower quality setting when you are producing the track, and you can have a higher or the highest quality when it's exporting the track. Some synthesizers have similar settings such as Diva. You have something called accuracy here. At the moment it's set to great, and you can select draft, fast, great, divine. And you have something called offline accuracy here. This is the off accuracy when you are exporting the track, and I always have it at best here, or you can set same and it will then match what you have in accuracy here. So if you have a slower computer, you can set it to draft, for example. You will get a little bit lower audio quality from Diva, but you will be able to run the project in real time. So another thing that can increase CPU load is if you, for example, use something like in the LFO here. So if I open up Diva, so you can see that the LFO here, it's actually adjusting the depth parameter on the chorus effect here, just to give it some unstableness. So if I turn it off, it's on 50-ish. So turn it on, it's a little bit more, but not much. But if you have a lot of LFOs in, I mean, if it adds up and it kind of increases the CPU load. I do this on other tracks here as well, just to try to give it some more analog feel. Here is also one LFO controlling the fine tune on the Kniphonium here, just a little bit. Can turn it off. Just loses life when I turn it on again. Gives it a little bit more life. I like to do this with synthesizers. So this is just a little production tip. Sometimes you just want to load up a preset and go playing, and sometimes you make your own sounds. But sometimes you have a preset, you play around a little bit, you play around a little bit with the parameters, and you kind of find this little sweet spot on a synthesizer. And in this sweet spot can be a really small as well. You kind of feel it has a small range. So instead of adjusting the VST in real time like you would do a real synthesizer, for example, I take the LFO and I just place it on that button or on that knob. I can, for example, loop something for 10 minutes here. I can loop this loop here for 10 minutes. And I can play with the parameters on the synthesizer and see if I hear some interesting sounds. And then I place the LFO on that parameter and I adjust it in that sweet spot. And it gives it a more organic feel. And it increases the CPU load a little bit. I do have some delay and reverb return tracks, and those tracks also have some processing as well. There are also even more plugins and effects on the master chain. I'm also using natural phase on my FabFilter EQ instances, but in production they are set to 0 latency to get a little bit better CPU load there. So this particular project I'm showing you here now is actually a little bit more demanding than it is needed. When this is finished, this is something that is being already sent to Spotify, so this could be a little bit less demanding when producing this. So the MacBook Pro M2 Max is handling this Ableton Live 11 session just fine, but I can't help to wonder when we are going to see some more efficient software. The system is just utilizing around perhaps 60% of the available resources, but at the same time when Ableton Live screams CPU overload. I did explore this a little bit in another video, but basically the reason for this is how the software is written and optimized, and the answer here can be quite complicated. I have done testing with Logic on my channel in some earlier videos, and it seems like Logic is more optimized, and naturally it perhaps should be because it's made by Apple, who also makes the Mac. The M2 Max is probably a little bit overkill just for Ableton Live or just for music production. If you don't need the extra graphics power, the GPU or the neural engines, you could go for the M2 Pro instead and save some money or put it in something else, perhaps upgrade the storage or memory or something like that. I have the M2 Max because of video editing and graphics. I would like to test the latest MacBook Air for music production because I think that is more realistic for most of you people getting, since the M2 Max is so expensive. But I have to wait to see if anyone is willing to take this off my hands for a good enough price, and we'll see what happens later on this channel if I'm selling this and going back to trying with the PC, the Ryzen system. I don't know, it's something that kind of people like doing on this channel, so we'll see. At least I hope this shows you a little bit how the machine works in an actual project. Personally, I like checking benchmark videos, reading spec sheets and all comparisons and numbers and all that. But there's a lot of people doing videos like that, so I don't feel the need to kind of saturate that market. So, but I also want to see how an actual product I want to buy works in real time, in addition to specs, of course. So I tried doing this with these videos. If you want to support, you can check out the track below. There's links to it, and there are probably other links below there as well. Other than that, take care, and I will see you in the next one. Goodbye.